learning throughout my PhD, and I'm trying to explain it into more bite-size methods. This technically should be more like video 4 or 5, because I'm actually explaining something that is fairly intermediate, but you can get an explanation of this up above here in the KAGGLE link, which I will be adding. And yeah, pretty much you can, from this video, learn and understand how simulation and genetic optimization can be done using the MESA library, and then the rest is just basic Python libraries that anyone can have. So the simulation is very easy. You have first the model, which acts as a environment within where agents do things. It's like a warehouse, and then you have workers inside it, and workers are the agents. So basically, right here, you have a list of jobs that must be done. Then you have workers, which are agents which do the work. And then what you're trying to do is you're trying to use this genetic algorithm to optimize for which job should be assigned to which workers, because obviously you have workers that work better, workers that work less. Now, the way the speed at which the worker works is set right here. It's set randomly as a salary. They have a higher salary, they complete the jobs quicker. So a job length is, let's say, 4. You simulate once, and then the salary, let's say the worker salary is 3. You just do 4 minus 3, then you have 1 more unit left. So then it would be the next simulation cycle. So yeah, basically you're trying to, ideally, if you have 2 simulation cycles and then it's a value of 4, maybe you should be assigning a worker that actually has a salary of 2 instead of 3. That could be something your genetic algorithm figures out. But yeah, basically your genetic algorithm has this search space, and it's basically searching within it with different steps. Now, obviously this code can look terrifying, and it's especially not the best for somebody that is new to computer science. That's why I will also be creating other videos later, within the week, within the month, explaining the different steps on how you can slowly build this. But basically, your genetic algorithm starts very simply. You generate a population of just random jobs. So you just, you assign jobs randomly to a bunch of people. Then you evaluate that population. Let's see if you see this on video. I hope you do. Actually, 1 second. There we go. Apologies for that. So let's say you have gene 1, gene 2, you have jobs 2, 3, 4, assigned to this worker, jobs 4, 5. So the way you can search the vector space, and the way that I did it was via 2 methods. One is crossover, where at each point, you pick 2 workers at random. And then you basically see, 2, 4, there's a chance of 50% to swap it, and then you can swap it. This is what we call a uniform crossover. So you just go through every single thing, and then you go to the next value, which is 3 and 5, and then there's a 50% chance to swap it. Now, when you get to 4, this worker doesn't have any more jobs, so you stop there. You don't do any more swapping. You can technically put it on at the end for 1%, like append. That is something you could technically do if you wanted. You can look within the code. I believe I didn't do this, but yeah. You basically just go through every single iteration and you just swap in between. Now, mutation is another thing that you could do, where you just have number 2 and then you randomly swap it with job 5. So that would be mutation as you're going through. Now, this iterative process, like these mutations and crossovers, you have to do over and over and over again. And you basically have to save the values that give you the best objective function. Within this work, the way we have assigned the objective function is, was the salary that we talked about earlier. You have a salary of 3 for this work, or you have a salary of 1. What you do is you'd get a sum of all of these values right here. And then within that sum, you just divide by the salary. And that would tell you how many simulation cycles it would take for that worker to finish that job. So that's basically what you're trying to get down as low as possible. And as you can see within the code here, if I run it all, which ideally it should run relatively quick. 265, yeah, here. You basically have the objective value, which starts very high at 500, and then it just slowly tapers down. By the time you have like 25 generations, it's kind of found a optimum within this area. Right now we're just doing crossover and mutation, and if you wanted to, you could take this algorithm further. You could expand it, make it more, make it just better than just having these two different values, because this might actually not be the true optimum value. You can only calculate if I see by hand, or I write entire search space, but that would take too long. And yeah, you also have this, showing the simulation progress, showing out each step, like, how the jobs are completed. This could be an example, like these tethering lines, instead of just having the, things going straight down. It's some things that, you could like think about the shape of that specific graph right here, the diversity of like these unique identifiers. I mean, these should be extremely unique, seeing as you're spreading jobs across. But then if your generated jobs are like, a job of like 2, 2, 2, 2, 2, which can happen in the generation, that'll give you some information. This isn't something that you have to worry too much about, but I guess if you run different simulation parameters or you run different seeds, that might change. And then this is just how, like per queue lengths, like how much each worker does work. I believe within this one, it seems to have just picked mostly to assign to 2 workers. But yeah, like this entire algorithm, at each step you can pretty much choose different methods. Crossover might not be the best. You could expand it. I mean, this is just a very beginner, well, not very beginner, but just it's not very highly in-depth genetic algorithm per se. However, it's offering a question problem which you could take and you could further expand. I mean, within this code, if you did want to actually get rid of my code, all you'd have to do is just delete this genetic algorithm part right here. This objective function, I would keep that the same, which is right here, and evaluate solution, I would keep that the same. But the rest within the genetic algorithm, you can delete. There might be a better way to generate the population. There's a lot of things that you could play around with this. And, in a way, this is kind of offering just a glimpse into how you can do how you can do optimization and simulation within the same amount of time. But yeah, I mean, this is simply just a glimpse. Apologies for that cut. But yeah, basically, you know, the idea of doing optimization just at the start is a very simplistic idea. The reason why for this, it's, you're just assigning work to workers at the start of the day. But within Mesa, if you were to not have this be on a KAGGLE, well, you could do it on a KAGGLE. It just might be a bit difficult as you'd have to, keep running different cells. Because like one limit, um, that is within this, it's like, like if you want to do anything like training or machine learning, it might not be the best to do within a cell if you want to like actually save this to a CSV, that kind of stuff, unless you want to just have this algorithm that, does all the simulation, then you train it, and then you put it back in the algorithm. Then you does the simulation, then you train it, and then you put it back in an algorithm. If you wanted to not learn at the same time as it's simulating, you know, then like basically, instead of learning like, okay, you've done one step of simulation, algorithm sees what the outputs are, learns from it, that you can't do within a KAGGLE. And within this, if I'm uploading anything to KAGGLE, I'd be explaining stuff like how to do the simulation, save those values, and then train it, or have the problem space be generated at the start and then just assign values to it. That's one limit of the KAGGLE. So if I actually get to explaining simulation and optimization at the same time, it would be something within PyCharm, which I'll be explaining in later videos. But yeah, I mean, if you wanted to do, this genetic algorithm, doing assignments and generating jobs as they come, like for example, you could actually go and take this into something like PyCharm. And what you would do is within this step, you just randomly generate a job in the job list. Then you'd have the genetic algorithm be called as at the step within the model. That's like where you're doing the assignment stuff. And this is one thing you really have to think about when you're doing simulation within Mesa. It's you have to think of, first I have the environment, then I have an agent doing stuff within the environment, and instead of like having the agents take like jobs from the model, it might just be better to do it all up there. That's always going to be a design choice. Personally, I just do it at the very top, and then pass it down onto the agents down below. Now, to say that you can't just have the job list within the warehouse and then you can have agents pick jobs, you can do that. It's just a lot harder to actually go from bottom up, because you don't really have too good knowledge of what job another agent might take. But one positive thing is, you're not running every single agent at the same time. You actually have to run each agent one by one. So like, as you see in this function right here, you could say you save your agents to a list of agents. And basically you have to do the actions for agent 1, agent 2, agent 3, agent 4, agent 5. So that could offer some benefits to doing bottom up. It does really depend how you want to set up your thing. But obviously, this is a very more intermediate and more higher level model. Now, within this KAGGLE notebook, you'll have, I basically explained all the variables, what they do, what each function does, that kind of stuff. So please do copy it and please do play around with it. Later in the year, I'll be creating explanations on how you can do every single of the steps, explaining stuff like abstraction, decomposition, inheritance. Those are all very important things that you need to achieve a good approach. So yeah, I hope you guys enjoyed, and please do play around with my KAGGLE.